Welcome back, everybody. Another technical demo. My name is Daniel O. I'm working for Red Hat as a technical marketing major. In this video, I'm going to walk you through the new cloud-native Java development workflow for Kubernetes developers. So let's get started. How does it look like Java development for Kubernetes? So first of all, you have to develop your own application on Java, and then you need to package it your own tool like a Maven Gradle, and then you need to create a Docker file to containerize that application. Next step, you need to build a container image using some Docker CLI or Podman or Builder, just your prepared command line tool, and then you need to push that container image into external container registries such as Docker Hub or Quay.io. And last step, you need to generate Kubernetes manifesto or OpenShift Container Platform manifesto, which is including some resources such as service deployment, etc. And lastly, you can deploy this application into Kubernetes cluster or OpenShift Container Platform. So Java developer standpoint, this all step they have to do address to deploy the application into Kubernetes cluster. This is a new daily task for developer, and then we have something different to make it quicker, make it more easier and convenient tool. All right. So I'm gonna introduce very quickly what Eclipse Jq. So Eclipse Jq is a collection of plugins and libraries for Java developer to use, and as well as build a container image using Docker or Zip, the Google container tool, or OpenShift source to image build strategy. So this tool generate and deploy Kubernetes and OpenShift manifesto and compile time as well. For Java developer, you can bring your Java application into Kubernetes OpenShift container platform as well by leveraging the task required to make your application cloud native. Zero configuration, which means automatically this tool allows Java developer to generate manifesto, and also you can just add Kubernetes or OpenShift Maven plugin on your application. Let's try to take a look at how it works in a demo environment. This is my demo environment, just a simple application. I'm going to use a Spring Boot application. It's one of the popular Microsoft's application. All right, this is just simple Spring Boot application. We're going to add some, for example, so generator to have a random UID. So in order to that, let's try to add a new controller here. So random generator and controller here. And first of all, we're gonna make this controllerless controller here, and then we just add one simple method here, just to return random UID, and then string and random. No need to parameter here, and then we just need to add gap mapping annotation because it's a new endpoint here, the random, something like that, random. Okay, and then return random ID, and we're going to use just a UUID and random UID. All right, and then just one more thing. Actually, I already run the multiple Spring Boot application based on 8080 ports, so that's why I just changed the support port 8180. Okay, just go back to controller, and then let's try to run this application using Maven plugin. So Maven Spring Boot and run. And it takes a couple of seconds to start up this application. Just to make sure to just simple task to access the endpoint here. So I'm going to split my terminal. All right, let's try to access the endpoint here using call command. So just call localhost 8180 and endpoint random. Okay, now we got it to random. So let's try it a few more time. Maybe we can use the infinite while loop to make sure the generate ID is keep changing. So we're gonna use that. So while and the true condition and do and just copy call comment here. and then maybe we just put in the sleep because it's maybe the result is super fast, and then just return code and done here. All right, so every single time, as you see, there are the random IDs automatically generated differently, right? I'm gonna zoom out once again, and I'm gonna stop the end result here. I'm gonna just close my terminal and start my local environment. So as you see in the slide stack, so next step, we're going to containerize this application. So, but for that, I'm going to make a package this application using Maven, command line, clean, maybe install. Just create the artifact like a jar file, my target directory, before I containerize this application. Just make sure to run the same application using jar command line and target directory in the demo application, and it works, and it just separate, and just a while and command line. So we just see here is a randomizer keep generating and the same result here. Okay, I'm going to stop the while loop and just close command line and stop the my local environment. So next step for Java developer to containerize this application, you can use the local Docker CLI. I'm going to deploy this application in my Kubernetes cluster. So today I'm going to use a Minikube, so which means if you want to use a Minikube, and you can also use Docker CLI, I mean Docker engine inside the Minikube. In order to that, you're just using Minikube Docker environment using eval command line. And now I'm going to, you can see the Docker images. So you can see the lot of Docker images inside the Minikube rather than your standalone the Docker engine. All right. So next step, I'm gonna containerize this application. But previously and traditionally, maybe you can use Docker CLI like Docker build, Docker etc. But I'm not gonna do that because we're gonna use the JQ plugin as I already explained. So when you just one thing you need to do, add the plugin here, Kubernetes Maven plugin or OpenShift Maven plugin. Once you add this plugin on your POM XML, you just need to Maven command line Kubernetes and build. So this command to build container image based on your application artifact, just like we you the Spring Boot. So as you see, the Kubernetes running, Kubernetes mode, and then you can use a Spring Boot application, etc. So let's try to make sure Docker create the Docker images and grab random here. So we just create a new container image 21 seconds ago, the random generator, the 1.0, and the register. Because when you go to POM XML, you will see here some property around JQ. So we're going to use the Java, we're going to use the JQ version 1.0.0, and you're going to use the JQ service type node port. This is actually, we're going to use this thing, our Kubernetes cluster. And then here is your container image name. This is my Docker Hub ID, and then the container image random dash generator and the version 1.0. That's why you can see here the random generator 1.0. So next step, we're gonna push this image actual external container image registry. The same thing you using the Maven command line, like Kubernetes, and push. So same command line, but we're going to use just a Maven program rather than a Docker command or Podman, Builder. This is more familiar with Java developer because sometimes, okay, what kind of command line, like a Docker CLI or a Podman or any other command line, do I need to use that for this stuff? But in this case, you just need to Maven plugin. So just build success, and I'm gonna open new window here, and then try to go to Docker Hub and make sure this is my image. And now you can see here the random generates just a few second update. All right, and close my window. And the next step, we're gonna generate the manifester to deploy our image into Kubernetes. In order to that, we're gonna use the Kubernetes command line plugin and also using resource. Once you generate some resource manifester, you can go to target directory, what kind of resources just generated. Under the classes directory and meta inf, you can see the Kubernetes YAML file here. And there are some resources like a deployment here, and also service here. And there you can see the application labeling demo, and just go to the SCR URL, and also the detail, the container image Docker of Daniel O, and then here is a random generator 1.0 image here. And also under the Kubernetes directory, you can find more deployment service YAML, which means you can deploy separately deployment or YAML resource into Kubernetes. All right, so let's try to make sure my Kubernetes cluster on Minikube in a namespace. I already create a namespace Jcube demo today here, and then I'm going to separate my terminal window and then just kubectl get path. There's no path at the moment because I didn't deploy any application into this namespace. Okay, let's try to deploy my application using the Maven command line and actually Jcube plugin in the Kubernetes, and apply or deploy. When you run this command line, it's automatically use your generate manifesto like a YAML file and into deploy. As you see, it automatically deploy your application here. So let's try to access this endpoint as the last point. Just kubectl get service object here. Now the node configuration in our POM XML. That's why this service is created based on node type to access more easily our application. So just using the code command and then Minikube IP address and this port 30944 port, using that, and random. So now we got the random ID and access to Kubernetes cluster, and also we can try to invoke this endpoint a couple more times using the infinite while loop as well, just like we did in a local test environment. And then just do just copy the previous command line. Let's leave just maybe just 0.5 seconds at this moment, and done. So now you can see how to keep generating the different random ID when you access the same application on Kubernetes. All right, just to recap what we run today in this demo. So we just run how to deploy and Spring Boot application on the Kubernetes cluster using Eclipse Jq plugin. It's really easy for Java developer. Even they don't need to run a new command line tool like a Docker CLI to build packaging and push it and deploy your application. Even they don't need to generate the YAML stuff to create a Kubernetes manifesto. So thank you for watching for this video and demo, and please make sure subscribe for the next interesting demo as well. Have a good rest of the day.